Good afternoon and welcome to Data Center. In our previous class, looked at different analysis. We considered the one-way ANOVA, two-way ANOVA, and then we also looked at we did post hoc text with visuals, okay, and then one of the post hoc tests we did in our last class was HSD, where we let's talk HSD, where we import the library from stats model, and then we did this is what we considered in our last class. Add the table, and then add this chart using this chart. That is the violin chart. The violin chart was what we used with error bar. Okay, look at this violin chart. This is the error bar. Okay. Then we also look at the LSD using the visual we used there was error bar. Okay, so this is what we considered in our last class. So basically today we'll be moving on, and then we'll be looking at using the same data set, Titanic data set. Okay, we will be checking different tests. Okay, today we will look at non-parametric tests. That's what we're going to consider today. Basically, if you look at the previous classes, we have been considering parametric tests. So today we'll look at non-parametric tests. We'll look at the Kruskal Wallis. We'll look at the Manju-Watney. Okay. Then, if time permits us, we proceed to check for normality of our tests using Chromograph, Smirnov, and then Shapiro-Wilk. Okay. So let's convert these to text. It's marked down. Okay. So we want to look at non-parametric tests. Okay, so that's what we're going to do basically today. Okay, so if you're just joining the class and you want to learn how to run different non-parametric tests, for information, you can go to Kaggle or GitHub and download this data set. That is Titanic data set. Okay, so once you have done that, then you can go to your search bar and then search for Anaconda. Usually I use the PowerShell. This PowerShell enables me to change my file directory. When you open your Jupyter notebook, it will open in a default directory, okay, and which may be difficult for you to import your data set. So basically what I used to do is to open through the PowerShell. So I will use the cd, meaning change directory. I created a desktop folder here called Python. This is it. So type cd and then followed by desktop, type desktop, then enter key, then you type cd, then my folder's name is Python, then Python, and thereafter you start your Jupyter notebook. And how to start your Jupyter notebook is to type Jupyter notebook and enter. Then the bash or the PowerShell will open your Jupyter notebook on your browser, and this is where we are. So you see, once it's open, the relevant folders and works that you have done in that folder will appear. So you can see you have all of them. The data sets you'll be working on, make sure that they are in the folder so that you can easily refer to them. Okay, so once you have done that, the first thing I did here, look at the first code here. I am using this library pandas and numpy, cbon and matplotlib.pyplot. Okay, Then I use my PD, that is the pandas, to read my CSV file, the Titanic data set. You can see it, and this shows just 5 rows. Okay, and then for next thing I do, if you are just joining us, once you've loaded in your data set, is to remove every missing row, that is data cleaning. Okay, so I said df, that is what is df, is the one containing, look at the df, is one containing my Titanic data set. Okay, so now instructing this that any of the row that is empty, that is not available, NA, I say it should be dropped. Okay, so that is what this line of code is doing. And then thereafter, move into pre-processing. Usually, when you are performing a statistical analysis and your data set contains string data, what you do is to convert it to numeric. So to do that, we use this library, label encoder. Okay, and I imported it from sklearn preprocessing. Okay, and then I said it should transform this, gender is male and female, so automatically transformed it to zeros and one. Okay, you can see right, 0 0 and 1. So you can scroll up to see what we have here. Okay, see, we have male, female, 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 male. Okay, so let's scroll down. Okay, okay, that's 1 2 3 4. 1 2 3, female, female. So female is 0 0 1, male, that is female is 0 and male is 1. Okay, so it is important we do this before we then perform our analysis, otherwise we have issues. Okay, so we will be looking at Kruskal Wallis, that is the first test we're doing here. Let me change this. So we have Kruskal Wallis test. Okay, all right. So we usually use a Kruskal Wallis test to test the differences, okay, between two independent groups. Okay, between two independent groups. Okay, between two independent groups. Okay, so I said we use Kruskal Wallis to test, to compare the differences between two or more than two independent groups. When you have more than two, okay, and then you want to test the differences between them. Okay, so we use Kruskal Wallis. Okay, and a typical example is your ANOVA. All right, so that is for ANOVA is for that is for parametric rather. So why for non-parametric is Kruskal Wallis test. So now let's go ahead. We're making use of scipy library. Okay, we make use of scipy library for these tests. Let's go. Okay, so from scipy.stats, we're importing Kruskal. So that is what we will be using. So we're importing Kruskal as a library from scipy.stats. Okay, so I want to check what, so I'll be adding visuals to it. So we have imported matplotlib. Okay, so there's no need to import matplotlib again here. Okay, so I want you to please follow suit, type in this code, just follow suit as we proceed. So now for this for the purpose of this test, what I want basically is the statistical value as well as the p value. Okay, so we have the stats, then the p-value. Then we're going to open our parentheses. We have make reference to the library, right? Then df, that is what is holding our data set. Then a square bracket, okay? And then we use this survived comma df p class. We have all these variables in our data set sex. Then we close. Okay, Then we can print, open our parentheses, then you put our f value, that is one line, okay. And if we like, we can print separately, okay, where we just put this. Let's go ahead and do this there. Let's do it this way, this way, okay. um, okay, as we have this Kruskal Wallis Test statistic. We have this, okay. Let's print another one. P value, and then we put what we have there, P value, okay. And close it, close our parenthesis. So let's run this and see. Okay, bravo, we have our results, okay. Look at the Kruskal Wallis age test statistic. We have 139, 139. Then we have the p-value. Okay, there's issue with the p-value. Let's correct it. Okay, let's run again. P-value, what's the problem? P-value. Okay, let's try this then. Let's try this. Okay, let's remove this. Let's run again. Okay, let's run this again. Okay, we have a p-value now, right? Yeah, correct. All right, so we have Kruskal Wallis age test statistics 139. The p-value is 4.754060. Okay, meaning that is not significant. Oh, see it? Okay, right. What is 2 power 10 raised by minus 3 3 1. Let's copy this value to see. Let's copy this value. Search for my Excel to be sure. To be sure. Let's try Excel. Okay. Okay. It's very slow. It's come. Is it scientific to general? Let's see. This is general. Okay. Okay. So it's significant. It's raised by 10 minus. So the p-value is significant. So I have to just change this to numbers to see if it is significant or not. So it's raised by 10, 4.75 raised by 10 raised by minus 31. So it is significant. All right. Now the relationship between this survivor, P class, and sex, when we compare the three variables together, we notice that there's significant differences between those who survive in this Titanic crash and the class in which they bought. Some are in economy class, some are in the moderate class, some are in the first class. Okay, and the gender. So there's significant differences between them. Now, the next thing to do to add more flesh to this result is to put it on visual. Okay, we want to add a visual to it. Okay, I'll be using ASL line from RainForest. Okay, after this, I will bring the real full coding for RainForest visuals. Okay, So this time I'm using PLT from matplotlib. We said, can you just follow suit? Said we are importing matplotlib.pyplot as PLT. So we are using our matplotlib here. So here's V line, that's what we are using, and we are saying the X is the start, then Y minimum is 0 and Y maximum is 1. The label, okay, that is F test stats, okay, and then we'll put our stats, then the color red, okay, PLT, so legend, right? Okay, then PLT dot show, let's show our visual. Okay, let's try these and see. Oh, bravo. We have our charts now. So if you look at this, we have the test the test statistics value, that is the Kruskal Wallis test, which is 139. Okay. Okay, I guess it's making sense. Look at this, 138, 139. Right, that is at the x axis. The x axis. All right. So let's see if we can use rainforest charts. I'll convert this now to rain rainforest. Rainforest, okay. This, all right. So I'm using this as well. So I want to use the rainforest visual to show comparison between the three. So we're still going to copy this time. All right. Okay, we're going to paste, but I have to remove this because I'm not going to use this time. So let's go. Okay, so for this, let's put this down. We need to bring the groups. To be able to use rainforest, we need to bring the groups. We need to calculate the means for the respective group. We also need to get the standard error, then the confidence interval, and then the overall mean of the data set. Is that okay? So we'll be using that for our rainforest because we are making comparison with your existing the mean compared to the overall mean. All right, so let's go with this. So calculate the mean now enter for each group. So for groups, we have this. We have this something. Okay, so let's calculate for the mean now. I have a df survive dot mean. Still remember the method. Okay, comma df p class dot mean df. I believe you know what is df. That is where we passed the variable that is holding our data set. Okay, set. Please follow suit as I'm typing the code dot mean. All right, so I'll close this now. This is calculation of the mean of respective group. Okay, then you have standard error. Okay. Okay, so error. Let's do it out. So for you to get the standard error rather, we have to get the standard deviation divided by the square root of standard error. So let's see. So this is the df survived. That is dot. We are bringing in the method of standard deviation here. Divide by this np dot square root ln then survive. Alright, so we have to get the square root of this. Okay, with this to get the standard error for survive. Okay, we'll put the same thing here, but this time around I'm going to change this to p class. Okay, p class. Okay, then we have this one is sex. Then we close the brackets, the square brackets. Is it this? So this also okay, yes. So it's a continuation. So this close this. There's an opening bracket. So this is a final bracket here. Next thing we're going to do is to calculate our confidence interval. That is, it must be plus or minus 1.96. That is the benchmark we are using, multiplied by the standard error. So we do for the low, that is minus, and the plus, the maximum. Okay. So we have this. So we have the confidence interval CI is equals to mean, that is the low, minus 1.96 multiplied by the standard error. Okay, for mean, X in zip means standard errors. Then standard confidence interval for I is equals to mean plus 1.96 multiplied by the standard error. For mean, right, the S is in zip means standard errors. Okay, so I haven't done this. The next thing to do is to then plot our charts. For you to plot a rainforest, it is important that you carry out all these exercises. You group the mean, the standard error, and the confidence interval. Okay, it is very, very important that you do that. After this, you can then plot a rainforest using the matplot lab. The next thing, the next thing we want to do is to show the fixed. Okay, we'll show the fixed size. Then thereafter, I want to plot for our I. Okay, we have this for I. Group in enumerate groups. Okay, palt error bar is the main as I. You are using the, if you remember, your for loop. Okay, under iteration. So then the x error at 1.96 multiplied by the standard error, the same I, and fmt 0, the label, so it should be group, and then the color blue. Okay. The next thing I'll be showing us, let's remove this now, is to add our overall mean. At this time around, for the purpose of this class, okay, I'll be using survive as a point of reference for overall mean. Okay, so that would be what all these will be compared with the other two variable. Okay, so you have a complete data set. Let's assume that these three are what make up your data set. So you don't need to use survive again. You just use the name of the data set, or you use mean method dot mean method again. So it's going to get you the mean of the entire data set. So for this, I'm going to use this as I said. I will change it later on to show you what I was saying. And then we have this. So I'm using survive dot the mean. This stands as the overall mean. Then I'll bring it to my ASV line because I want it to be a vertical line. Okay. Then we have this overall here. The color said it should be blue. Then the line style, look at the dash, dash, line, dash. Then label overall mean. All right. Set our tick. Set our tick now. So we have white tick, we have range, then groups, and then groups. Then we have PLT, the S label, we have the mean value with 95% confidence interval. Then the title, we have forest plot of group comparison, Kruskal Wallis Test. Then we have this. And the next thing is our, let's show our legend and the likes. Okay, let's show our legend, LOC, that is location, upper right. Hmm. Okay, okay, the next thing is show types, layouts, and show. Let's run and see. That's what we have. We have an error somewhere, so let's quickly check. Standard errors not defined. Let's check. The advantage of this is you can easily debug your work. Standard errors. Where do you make reference to standard errors? Okay, these. Let's put this then. Let's put X here. Okay. So my code has changed. Let's run and see. Bravo. Wow. So you can see now we have the survive, we have the class, we have the sex. So you can see the mean value with 95% CI. You can see my I say location upper right, that is LOC, upper right. Okay, so it should be tight. Okay, it's longer 8, and the other one is not as long as this. That's 8.5. Okay. If you look at this, so you can see this is forest plots. Okay. Okay. I want to quickly make some. Okay, let's assume that. Okay, we show that as overall mean, right? It's there. Okay. But since I'm not using overall mean, I can change it to survived. Survived. Let's see. Let's see. See it survived. Okay. So that is what we're comparing it with. Okay. Now let me make some other changes. Oops, group. Okay. For the overall mean. Okay, let's quickly make the changes. Right, I was saying something that should in case the three are together in a particular data set and then you want to get the overall mean for that data set and use it as a means of comparison with the stray. So what you do instead of using survive as I did is just to do this, the name of the variable holding the data set dot mean and then run. See. All right, you can see. So bravo, I've changed. So you can see that straight line, the vertical line moved straight more than 70. Okay, so that is what you have to do, please. So I can then change this to, let me please change this to overall mean. Okay, you can see. All right, so what if we are, you see, all the other variable now move to 0. So what, let's quickly change this. Let's go back to what we were doing before and change it to survived. Okay, and these two survived. Okay, can run now. Bravo. So you can see. So this is RainForest showing the differences between the three groups, and we use Kruskal Wallis. All right. So please, I want you to follow the code one after the other and practice. If you are just joining for the first time, please do well to subscribe and invite others to follow through the class. If you have any question, you can always slide to my DM and then you will be assisted. Thank you for listening. Now, next class we'll look at Manju Watney. Okay.